Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on IIR filter design. That is nothing but realization structures for IIR filters. See, first we can see the comparison of digital and analog filter. See, digital filter is nothing but operates on the digital principles of the signal. Analog filter, it operates on the analog signals. Digital filter is governed by linear difference equation. Analog filter is governed by linear differential equation. Digital filter consists of adders, multipliers, delays, etc. Analog filter consists of electrical components like resistors, capacitors and inductors, etc. Now, what is mean by impulse invariant transformation? The impulse invariant transformation is to develop an IIR transfer function whose impulse response is the sampled version of the impulse response of the analog filter. The Laplace transform of the analog impulse response h of t gives the transfer function of the filter. H of s is equal to Laplace transform of h of t. 1 by s plus pk is equal to 1 divided by 1 minus e power minus pk into t into z inverse. This is nothing but impulse invariant transformation from S plane to Z plane. The left half of the S plane is mapped into the unit circle in the Z plane. And the right half of the S plane are mapped into the outside the unit circle in the Z plane in impulse invariant transformation. Next, bilinear transformation is a conformal mapping that transforms the imaginary axis of S plane into the unit circle of the Z plane to avoid aliasing. In this mapping, the left half of S plane are mapped inside the unit circle in the Z plane, and all the points right half of the S plane are mapped into the outside the unit circle of the Z plane. S can be defined as 2 by t into 1 minus Z inverse divided by 1 plus Z inverse. T is nothing but sampling time period. This is the left half of S plane are mapped into the inside the unit circle of the Z plane. The right half of the S plane are mapped into the outside the unit circle in the Z plane in bilinear transformation. Next one is Z transform. Z transform is used for the analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time signal as well as system analysis. X of n and X of z form the Fourier transform pair. From the X of n term that can be converted into imaginary of Z. Next one, system transfer function. System transfer function can be defined as ratio of the output to the input. H of z is equal to y of z divided by x of z. Frequency response, h of omega is equal to y of omega divided by x of omega. Next one, difference equation. It is an efficient way to implement discrete time systems. The convolution of input sequence at a unit sampled response gives the output y of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Next one, finite impulse response. Unit sampled response or impulse response h of n has finite number of terms. Y of n is equal to summation k is equal to 0 to m minus 1 h of k into x of n minus k. IIR systems, length of the unit sampled response as h of n is infinite. Y of n is equal to summation k is equal to 0 to infinite h of k into x of n minus k. Next one, recursive and non-recursive systems. Recursive system output y of n depends on present and past input as well as past output. Y of n is equal to summation k is equal to 0 to n into x of k. Non-recursive system output y of n depends on present and past input. K is equal to 0 to m h of k into x of n minus k. Now we can see the applications of Z transform. It is used for the analysis of discrete time systems. It is used in digital signals. It is used to solve the mode difference equations with constant coefficients, to characterize the transfer function of discrete time LTE systems, to design a digital filter. Next one, structures are, the discrete time systems are represented by block diagrams. They are called as structures of discrete time systems. It can be classified into direct form 1, direct form 2, cascade form and parallel form. First we can see the summary of elementary blocks. Adders, x1 of n added with x2 of n gives x1 of n plus x2 of n. Constant multiplier, when we multiplied with constant term a into x of n. Unit delay elements means minus indicates delay. X of n multiplied with z inverse we can get x of n minus 1. signal multiplier x1 of n multiplied with x2 of n, therefore x1 of n into x2 of n. Advancing element means plus indicates advancing. Y of n is equal to x of n plus 1. Multiplication x1 of n multiplied with x2 of n gives output as y of n is equal to x1 of n into x2 of n. This is the block diagram representation. Y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. X of n multiplied with z inverse, we can get it as your x of n minus 1, that can be added with multiplied with y of n multiplied with z inverse, we can get y of n minus 1, that can be added with 0.5 into x of n. Gives the block diagram representation. This is the h of z is equal to 1 divided by 1 minus a z inverse. Therefore, x of n multiplied with your a, where we can get it as your z inverse, we can get it as your y of n. Again, x of n multiplied with your z inverse, we can get x of n minus 1. Multiplied with your a, we can get it as your output as your y of n. This is the given block diagram representation. Next one, y of n is equal to a1 into y of n minus 1 plus a2 into y of n minus 2 plus b0 into x of n. That is y of n multiplied with z inverse, we can get a1 into y of n minus 1. Again multiplied with z inverse, we can get a2 into y of n minus 2. Gives the output as b0 multiplied with x of n, we can get b0 into x of n plus a1 into y of n minus 1 plus a2 into y of n minus 2. Next one, we can see the direct form 1 structure. Y of n is equal to 3 by 4 into y of n minus 1 minus 1 by 8 into y of n minus 2 plus x of n plus 1 by 2 into x of n minus 1. X of n multiplied with your 1 added with 1 by 2 into z inverse into x of n. Right? We can get y of n gives the output as y of n. Y of n minus 1 means multiplied with z inverse, we can get y of n minus 1. Multiplied with 3 by 4, we can get 3 by 4 into y of n minus 1. Again multiplied with z inverse, we can get y of n minus 2. Multiplied with minus 1 by 8 constant term, we can get minus 1 by 8 into y of n minus 2. Next one, direct form 2 structure. This direct form 2 structure is 3 by 4 into y of n minus 1 minus 1 by 8 into y of n minus 2 plus x of n plus 1 by 2 into x of n minus 1. See, in direct form 2 structure, y of z divided by x of z is equal to y of z divided by w of z into w of z divided by x of z. X of n multiplied with 3 by 4 into z inverse, therefore which can get 3 by 4 into x of n minus 1. Again multiplied with z inverse, x of n minus 2 multiplied with minus 1 by 8, we can get x of n minus 2. Y of n is nothing but multiplied with z inverse, we can get y of n minus 1 multiplied with constant term 1 by 2 into y of n minus 1. This is the direct form 2 structure. Similarly for cascade and parallel, we can get it as your 1 plus z inverse, 1 plus z inverse divided by 1 minus 0.5 into z inverse, 1 minus 0.25 into z inverse. Parallel form, we can apply the partial fraction method, we can get it as your 8 plus 18 by 1 minus 0.5 z inverse minus 25 divided by 1 minus 0.25 z inverse. First we can see the cascade form structure. Say 1 minus 0.25 is the inverse. We can get x of n multiplied with 1. We can get 0.1 minus 0.25 is the inverse. Then numerator term is 1 plus z inverse. Gives similarly for output function 1 minus 0.5 into z inverse, 1 plus z inverse. Finally, we can combine these two signals. We can get it as your cascade form. Similarly for parallel form, x of n multiplied with constant term 8. Again x of n multiplied with your 0.1 minus 0.5 is the inverse, multiplied with your constant term is 18. Again 1 minus 0.5 into z inverse multiplied with your minus 25, we can get the similar. This is the parallel form structure that can be simulated in parallel, gives the output as y of n. Now we can see the assessment. Define Z transform. Z transform is used for the analysis of discrete time signals. It is very broad compared to discrete time Fourier transform. X of n and x of z form the Fourier transform pair. What is mean by bilinear transformation? Bilinear transformation is the conformal mapping where the imaginary of the S plane is mapped into the unit circle in the Z plane. Mention the structures to represent block diagram: direct form 1, direct form 2, cascade and parallel. Compare digital filter and analog filter. See, digital filter based operates on digital signals. Analog filter operates on analog samples. Digital filter is governed by linear difference equation. Analog filter is governed by linear differential equation. The system transfer function of LTE DT system is H of Z is equal to Y of Z divided by X of Z. Output divided by input. List the summary of elementary blocks to represent discrete time systems: adders, multiplier, constant multiplier, delay element, advancing element, etc. Identify the difference equation. X of n is equal to, therefore we can get it as 0. Y of n is equal to y of n minus 1 multiplied with your constant a term. Therefore x of n is equal to a into y of n minus 1. Thank you.